Hello and welcome to Chemistry News. We just received breaking news of a student in need of assistance on a topic called net ionic equations. Our fellow reporter will give you a crash course on how to successfully write net ionic equations. The first thing you need to know about net ionic equations is what exactly a net ionic equation is and what it is used for. By definition, a net ionic equation is a chemical equation that only displays the elements, compounds, and ions that are directly involved in a reaction. A net ionic equation is commonly used in acid-base neutralization reactions, double replacement reactions, and redox reactions. To be able to write a net ionic equation, you must be able to predict the products by knowing the type of reaction and how the ions are exchanged to form the products. You must know how to balance a chemical equation, and you must know the solubility rules. Knowing these will allow you to find the complete net ionic equation and then the net ionic equation. For the solubility rules, a helpful way to remember which compounds and elements are always soluble is the mnemonic NAGSAG. NAGSAG represents nitrates, acetates, group 1 alkali metals, sulfate, ammonium, group 17 halides. These are always going to be soluble. Remember the mnemonic CastroBar for the exceptions for sulfate. CastroBar stands for calcium, strontium, and barium. Remember the mnemonic PMS for the exceptions for the group 17 halides. PMS stands for lead, mercury, and silver. Some helpful tips when it comes to writing net ionic equations are to always remember that solids are not written as ions. It is also important to always include the states of matter. Although it is not always required, it is important to make a habit of doing so. Now, let's begin with an example. In this video, we will be going over the double replacement reaction of potassium chloride and lead nitrate. In this scenario, the potassium will come together with the nitrate, and the lead will come together with the chlorine. But, before putting the products together, we must determine the ions in this reaction. By looking at the periodic table, we can determine the charge of the ions. In potassium chloride, potassium has a positive 1 charge, and chlorine has a negative 1 charge. For lead nitrate, the subscript 2 next to the nitrate will swap across and become the positive 2 charge for lead, and nitrate will have a negative 1 charge. It would be helpful to memorize the charges of the more common ions like nitrate. Now that we have established the charges of the ions, let's put together the products. We will gather the potassium and nitrate. The charges will swap across, forming potassium nitrate, and the chlorine and lead will come together, forming lead chloride. The next step is to balance the equation. The new chemical equation would be 2 potassium chloride plus 1 lead nitrate yields 2 potassium nitrate plus 1 lead chloride. The next step is to assign the states of matter. Looking at the solubility rules, potassium is in group 1. Group 1 is always soluble. Chlorine is a halogen that is also soluble, but with the exceptions of PMS, or lead, mercury, and silver. This means that KCl is soluble, or aqueous. For lead nitrate, the solubility rules state that nitrate is always soluble with no exceptions. This means that lead nitrate is aqueous. This same rule applies to potassium nitrate. This means that it is also aqueous. Lastly, when looking at lead chloride, we know that chlorine is a halogen which is soluble with the exceptions of PMS. Seeing as it is paired with lead, this means that lead chloride is not soluble and is therefore a solid. Next, we will break up the compounds. For KCl, the coefficient 2 is distributed to each ion. As we found the charges earlier in this video, we know that KCl dissociates into 2K plus and 2Cl minus. For lead nitrate, we have Pb2 plus and 2NO3 minus. This is because of the subscript 2 next to the nitrate in the top line. Following, we have 2K plus and 2NO3 minus and PbCl2. Remember that solids are not written as ions. We put this together and we have the following equation. This is the complete net ionic equation. In a complete net ionic equation, there are ions called spectator ions. Spectator ions are ions that do not partake in a reaction, meaning they will be found on both sides of the equation as products and reactants. When looking at this complete net ionic equation, I can see that 2K plus is on both sides of the equation. This means I can cross this spectator ion off. I can also see that 2NO3 minus is on both sides of the equation, meaning I am also going to be crossing it off. The remaining ions are 2Cl- plus Pb2 plus yields PbCl2. We can now bring these down to form our net ionic equation. Our net ionic equation will be 2Cl- plus Pb2 plus yields PbCl2. I hope this helped. Thanks for tuning in on an episode on Chemistry News. See you next time!